A set of types of reaction deals with, see, exothermic, endothermic dealt with energy release हो रहा है कि absorb हो रहा है. The next set of reaction deals with reaction में क्या हो रहा है, like what's happening to the reactants and products. So combination reaction में, again it's like right there in the name, combination. So कुछ combine हो रहा है. So reaction in which two or more substances, so if we have two substances A and B reacting, they combine to form a single product. So that's combination reaction. Okay, you guys noted down the definition, combination ke? Done? Cool. Examples of combination, yeah, is what we're looking at. See, all the combustion reactions, specifically the combustion of elemental stuff. So carbon plus oxygen, this is basically coal burning, gives CO2. Two elements combining to form a single product. Magnesium plus oxygen gives magnesium oxide. Copper plus oxygen gives CuO. Do you guys remember the reaction for slaking of lime? Anyone tell me? What is the chemical reaction? What is lime and what is slaking of lime?
Quicklime plus H2O, CaO plus H2O becomes CaOH2 calcium hydroxide.
There you go, correct. Quicklime is CaO plus H2O. Slaking is basically dissolving in water, gives CaOH twice. This is extremely exothermic. That's where we saw the reaction. But also, we have two substances combining to give single product. This is also a combination reaction. Preparation of water, like all these preparation from the individual elements. Water is formed from hydrogen and oxygen. HCl from hydrogen and chlorine. And ammonia is formed from nitrogen and hydrogen. So these are the equations. But these equations are not balanced. Arya, can you balance the first one? So Arya, you balance the first one. Crystal, you take the second one. HCl wala reaction. Tell me what should be the balanced equation. And who will take the third one? Kashvi, do the third one. Ammonia wala equation. Give me the final one. Gautam, you can send it on chat, but like don't send it to everyone. I'll check. But when you note it down in your book, write down the balanced equations only. So all these cases, you can see there's two substances combining to form a single substance. So all of them are combination reaction examples. Hi Anna, good afternoon. Anna, can you switch on your video? Gautam, you already got the water wala reaction absolutely right. Do the others also. Anna, you all set? You here? Okay. Hello.
Yes, ma'am. Good afternoon.
Cool. We're looking at combination reactions. Did you catch the recording of last week?
Yes, ma'am.
Okay, cool. So yeah, so these are examples of combination reactions. So these reactions are not balanced. So when you noted them, note down the balanced equations. Okay, Mahak has sent all three. Gautam also got all three. Good, good work, guys. Practice kiya aapne. Whose was the first one? Who did I ask to answer? Arya. Kashvi sent the ammonia wala equation. Check, hydrogens are not balanced. That could be a typo, could be a calculation mistake. Either way, just check what you sent, Kashvi. So Crystal, you are to give me the answer for this one. Iska balanced equation.
So H2 plus Cl2 is 2HCl.
2HCl is absolutely right. Very good, correct. Arya has also answered. So this will be 2H2 plus O2 gives 2H2O. Arya, don't use equal to. I mentioned this in a previous class. Agar arrow dena hai, so you can put 1 or 2 hyphens and use the greater than less than symbol. Okay, don't make a habit of writing equal to in this case. Kashvi, yes, you've corrected it. Ammonia is N2 plus 3H2 gives 2NH3. Okay, so these are the balanced equations. Okay. So once everybody's finished noting down, I'll go. If someone's still writing, let me know. Otherwise, I'll go to the next part.
Ma'am, can you show the definition of the difference?
So reactions in which 2 or more substances combine to form a single product. This is the main. So combine हो रहा है combination. Okay. Yeah. Yeah, are you done? Kia, finished writing?
Yes, ma'am. Yes, ma'am.
So combination के बाद the next one is right opposite of combination reaction, decomposition. Do you know the meaning of decomposition?
Breaking down.
Breaking down, correct. So even in decomposition reactions, that exact same thing is going to happen. So you have a single big compound that breaks down into 2 or more products. So reactions in which single reactant decomposes into 2 more products is called decomposition reaction. Yeah, so write down the definition, then we look at what are the examples and types of decomposition reaction. Okay, सबका खत्म हो गया decomposition? या पार्वती आशका?
Yes, ma'am. Done.
Yes, ma'am. Done.
Okay.
Ma'am, done.
ठीक है. So decomposition, you're breaking apart a compound, right? So when you want to break a bond, like split the atoms away from each other, you need to give them some energy in order to do that. So think of it as like magnets. Have you guys played with magnets? Who all have played with magnets? Could be fridge magnets, it could be magnetic toys, jo bhi hai. Just filled around with magnets. So magnets, okay, they, let's say they attracted each other, and when you went to separate them, what did you observe? Like, was it easy to just pull them apart, or did you have to like spend some effort, some energy in like separating them?
And you have to put some energy into separating them.
Right? So think of chemical bonds also in a similar manner. Like suppose we have water, which is H2O, you have oxygen and 2 hydrogen, right? So why is this water? Like you have an oxygen atom, it is bonded to 2 hydrogen atoms. Bonded matlab kya? They're sharing a pair of electrons between them. Bond is basically just a pair of electrons. So in order to break this bond, just like how you needed to put an energy to separate magnets, ये bond break करने में भी थोड़ा energy देना पड़ता है. So compounds usually need energy to split into other substances. So because you have to give energy, a lot of decomposition reactions also end up being endothermic. Okay. So depending on how you give that energy, you have different types of decomposition reaction. So अगर heat energy दे रहे हो, so heat means thermal, like इसलिए you have thermos flask, thermometer. Therm मतलब related to heat. So for heat you have thermal decomposition. Light, again photo, all Greek and Latin words. So light related to photo, so it's called photochemical decomposition. So literally it's like light say chemicals ko you're breaking down. So photochemical decomposition. Another name you can use is photolysis. So this word lysis, wherever you come across it, again some either Latin or Greek origin. So lysis ka meaning is breaking down. So photolysis is literally light, say you're breaking it down. Similarly, if you provide electricity, then that is called electrolysis. So electrolysis, electricity, say you're breaking down. Lysis meaning breaking down is pretty, like you'll come across it a lot in like chemistry and biology. Like 9th May you must have come across lysosomes, right? So all similar meanings, like wherever you come across lysis means breaking down. Okay. So we'll look at each reaction one by one. Like first we look at thermal decomposition, and photolysis, and electrolysis.
Ma'am, just once can you show a definition one more time?
Definition, okay. Yeah.
Then,
Cool. So decomposition matlab you're breaking it down. So in order to break something down, you need to give it energy. So depending on what energy you're giving it, it's either thermal decomposition or photochemical decomposition or electrolysis. Okay. Gautam still noting down. Okay. Tia, Ashka, Parvati, tell me once you finish, we'll go to the next part.
I'm done.
Huh? Cool.
I'm done.
Okay. I think Arya is also noting down. Okay. Tia, finished?
Yes, ma'am.
The first is thermal decomposition. Best example is decomposition of limestone. There you go. Lime basically is a calcium ka compound. So limestone is calcium carbonate. Other common names for this, what is calcium carbonate? It's basically chalk. So the same chalk, blackboard pe likhne ke liye you use it, right? So that's limestone, that's calcium carbonate. And calcium carbonate, you also see it marble. So marble, come across marble, it's like chemically, if you look at it, it's calcium carbonate, limestone. So when it's in like the mineral form, like abhi bhi earth mein hai, if you're like mining it, then it's called limestone. Yeah. So thermal decomposition, limestone is an example, because when you take a little bit of limestone, calcium carbonate, and you heat it, take it in a plate or a test tube or something of that sort, heat it, it decomposes into CaO and CO2, calcium oxide and carbon dioxide. Okay. Do you remember what is calcium oxide? Its common name kya hai? Who remembers? Let's see.
Quicklime.
Nice. Good job. Quicklime is correct. So calcium oxide, CaO is quicklime. Okay. Just note down the reaction. This is just putting it in words. Limestone is heated, it decomposes into, oh, it's given right here, quicklime and carbon dioxide. Now, how do we know that a reaction has taken place and ऐसा नहीं हुआ कि बस limestone का ही temperature बढ़ा है? Like, how do we know that calcium carbonate has turned into this? Because visually, this is also like white stone salt type thing. CO quicklime chuna is also like a yellowish whitish substance. तो पता कैसे चला है कि this has changed into this? Can you think of any way you can, like, if you have to prove it to someone, or if you had to know कि क्या है वहाँ पे reaction हो रहा है कि नहीं हो रहा है? Can you think of a way?
We can say that heat is taking place during the reaction, and we are noticing that something has been formed, that is the quicklime, which is a white powdery substance, and there is gas separated, which is CO2.
I mean, technically you're right, but practically speaking, if you imagine it, chalk piece का color क्या है?
White.
White. So when I'm heating chalk piece, how do I know that that has turned into quicklime, which is also white, instead of iska temperature only has increased? Like, how do I know that? Yes, Rajat.
Yes, I'm trying this. So when we heat calcium carbonate, so it decomposes into calcium oxide, so quicklime and carbon dioxide. The carbon dioxide is gas. So calcium oxide is in a, if we take a bowl, for example, so calcium oxide is there. So and if we add H2, that is water, it turns into CaOH2. And when CaOH2 comes in contact with carbon dioxide, it turns milky.
That's interesting. That's a good test. You're thinking on the right lines, but we'll just like fine tune it a little bit. Okay. So first of all, like initially, let's say if I take 100 grams of calcium carbonate and if I heat it, it's gonna turn into calcium oxide and carbon dioxide. Okay. So carbon dioxide, as Srijak said, it's a gas. So what happens to the carbon dioxide? Will it stay in the test tube in the bowl itself, or will it, like, what will happen to the gas?
It will leave the test tube.
It leaves. Gas hai, it's gonna fly out into the atmosphere, right? So this has escaped. So when I measure whatever calcium oxide I have remaining in the test tube, iska mass kya hoga? Will it increase, will it decrease, or will it remain the same?
Ma'am, CaO's mass will decrease because its carbon and oxygen has been lost in carbon dioxide also.
Correct. जब मैंने initially लिया इस calcium carbonate, उसका मास है 100 grams, लेकिन उसमें से carbon dioxide निकल गया ना, which means whatever I have remaining, it should be less than 100 grams, should mass decrease होना चाहिए. So that's like hint number one, कि because the mass has decreased, calcium carbonate is not remained as it is, like it has changed somehow, and mass has lost, matlab some of it has escaped into the atmosphere. Now here comes the second test okay, what gas has escaped out in the atmosphere? Like, what do we have here? How do we know this is carbon dioxide? So do you guys remember what is the test for carbon dioxide?
Ma'am, carbon dioxide, like it was mentioned in class 9 that carbon dioxide turns lime water milky.
There you go. That is correct. Turns lime water milky. Can you tell me what happens like chemically there? What is lime water? What does it mean if it turns milky? क्या हो रहा है reaction?
Ma'am, lime water is CaOH twice,
Correct.
and when carbon dioxide is added to it, then hydrogen is also released, and CaO.
Hydrogen is not released.
Okay.
You're on the right lines. This is lime water. We are adding CO2 in it. Now focus on the milky part. Milky क्यों हो रहा है? Milky मतलब there is something white being produced solution में. इसलिए
carbon
There's a white
calcium carbonate
precipitate formed.
किसका precipitate है वो?
Calcium carbonate.
Absolutely, very good. Got there in the end. Okay, so the white precipitate is calcium carbonate, CaCO3 plus H2O is produced. Now CaCO3 is insoluble. Insoluble matlab it does not dissolve in water. It can't dissolve off in water. इसलिए वो transparent नहीं है. And this is a white substance, right? So white substance you add it to water. This is the thing that makes it milky. So this is the test for carbon dioxide that you guys have learned. Chemical reaction test में क्या हो रहा है? What is milky? Why is it turning milky? So the milky substance is calcium carbonate, and वो observation मिल रहा है. It's turning white in color because it is not soluble in water. So बाहर precipitate होके बाहर आ जाएगा, and that's what we see as a white substance being formed. That's what we call as being milky. Okay, so finish writing this यहाँ तक, and then I'll show you guys the visual कि क्या हो रहा है, कैसे दिखेगा. Okay, Gautam is done. Arna is also done. Mahak finished writing.
No, I'm done.
Is that Parvati is done? Okay. Srijak finished writing. Okay. So Krystal, Tia, Ashka, you guys let me know once you're also finished, and then
Done.
cool.
Just a minute.
If you want, you can mention this is transparent. Like पूरा dissolve हो जाएगा calcium hydroxide, so it's like initially when you take it, it's transparent. Reaction होने के बाद the change is transparent became milky.
Yes, I'm done.
Yep. We'll not look at this video because some problems with this, but I found another one here.
Detecting carbon dioxide gas using clear lime water. Calcium hydroxide, which is known as clear lime water, is used to detect the presence of carbon dioxide gas produced from the reaction of sodium carbonate or sodium bicarbonate salts.
So we did decomposition of calcium carbonate. Here they're going to produce carbon dioxide from a different reaction. Okay, so don't worry about it. Just know that इस reaction से carbon dioxide आएगा.
With diluted hydrochloric acid,
reaction से carbon dioxide produce हो रहा है. Now observe
by
this step.
passing the gas through clear lime water.
Okay, so this is clear lime water. Now bubbling has started. मतलब यहाँ से carbon dioxide gas is being passed here. Let's see what happens. Now keep observing.
What do you observe? Clear lime water turns milky.
Now we can see this one has become pura white. So here I'll ask you guys a question. What is there in this test tube? Like what all chemicals, what all substances are there over here? Makes it milky.
Calcium carbonate
Okay, only calcium carbonate
plus water.
plus water. Yes. Yeah, so calcium carbonate plus water dissolve नहीं हो रहा है इसलिए पूरा it's white. Okay, now let's see further. Now,
On passing carbon dioxide gas through it for a short time, due to the formation of springly soluble calcium carbonate in water.
here is the reaction.
On passing carbon dioxide gas for a longer time,
Okay, so he has not removed the tube from this test tube. You have seen yourself कि पहले milky था. Now what do you see? What's happening in this test tube here? I'll mute it and I'll like take it to a close up.
It's becoming transparent.
What is happening here?
Becoming transparent.
It became transparent again.
Yes. Why did this happen? Reverse to nahi hua because carbon dioxide has been passing through it continuously. So what happened here?
Ma'am, did it
Settle
like
down.
settle down?
Settle down नहीं. अगर settle down हुआ तो I'll clear the drawing. तो नीचे कुछ तो दिखना चाहिए ना. This whole thing is like properly, clearly transparent.
Has it escaped?
Huh?
Has it escaped?
No. I mean, calcium carbonate solid hai. It's not like, think of your table salt. That's not going to escape anywhere, right? Gas to nahi banai wo. Okay. So what happened here is, let's go back to our reaction to see क्या हो रहा है. तो अभी क्या हो रहा है? Like हमारे test tube में we already have calcium carbonate plus H2O. So this is like your milky solution, right? Giving the milkiness. Now you keep passing on carbon dioxide, excess CO2 hai. So we can write it here. On passing, if you keep on passing that carbon dioxide on passing excess carbon dioxide. So already solution में we have lime water transparent turned milky. Abhi isme we're still passing CO2. So what happens is a different substance. So this is gonna react with the water and carbon dioxide and produce calcium bicarbonate, which is CaHCO3 taken twice. Now calcium bicarbonate is soluble, which means as soon as the substance is formed, जो भी पानी है test tube में, it's gonna dissolve, and because it's dissolved, that milkiness disappears. So it becomes transparent again.
Sodium bicarbonate is soluble in water, right?
Yeah.
Like, sorry, that's just what you wrote.
Yes. So calcium carbonate is insoluble, but bicarbonate is soluble in water. And then this calcium bicarbonate. Another way, some textbooks also call this calcium hydrogen carbonate, because you have hydrogen and you have carbonate. So don't get confused, same thing it is. Bicarbonate or hydrogen carbonate is the same thing. Yeah. So this calcium carbonate is insoluble, इसलिए it looks milky, it's white precipitate. This is soluble, so it dissolves in water, so that solution becomes transparent again. That's essentially what happens there. Okay, so test for carbon dioxide, there's a two-step thing. Your immediate first reaction is lime water turning milky. But if you keep letting that happen, if you keep passing carbon dioxide and passing excess CO2, the milkiness becomes transparent again. Why? Because you have soluble calcium bicarbonate being formed there. Okay, so once you finish writing down, we'll go back to that video, watch that again. Kashvi is still noting down? Finish. Okay. Shrija, Tia, Parvati, Ashka.
Yes, ma'am.
No, I'm done.
Okay. Tia and Ashka?
Yeah, ma'am, I'm done.
Okay. I'm gonna unmute and start where we left off.
Stringly soluble calcium carbonate in water.
Calcium carbonate is formed. This you guys are familiar with. You just
On
need to-
passing carbon dioxide gas for a longer time, the precipitate disappears, since insoluble calcium carbonate changes into soluble calcium bicarbonate.
Right. So dissolve ho gaya, so it becomes transparent again. That's what happens in the reaction. Okay. You guys got that, or you guys wanna like watch it again? Got it. Got it? Okay. Cool. So coming back, yeah, we were studying about thermal decomposition. Decomposition of limestone calcium carbonate on heating, इसलिए thermal decomposition है, gives calcium oxide and carbon dioxide. So how do you know this reaction has happened? One, there is a change in mass, which tells you कि कुछ तो gas escape हुआ, और कौन सा gas escape हुआ? You have test for CO2 right there. Turns lime water. Okay. What are you guys writing? Should I go to the next slide or noting something here?
Just a minute, noting.
Okay. Okay, so I mean, instead of noting this down, I would rather you guys note this whole thing for test for CO2, because यहाँ पे reactions भी आ गए, observations भी आ गए, so this would be better and more important. Okay, ये खत्म हुआ,
Ma'am,
like
can you just show the formula?
which one?
The equation.
Yeah, these are
On
the
the paper.
equations. Thermal.
No, on the paper.
Okay, this is the equation decomposition का.
Yes.
Cool. Another example of thermal decomposition. So decomposition of lead nitrate. So similar to this, you also have decomposition of iron sulfate. Exam point of view, this is more popular for decomposition reaction. Like in general, figuring out kaun sa reactant, kaun sa product also is asked quite a bit. Lead nitrate is a salt, ionic compound here. Lead is Pb, nitrate is NO3. So lead nitrate formula, like valency के साथ match करके, it is Pb3, PbNO3 taken twice. So when you heat this salt, this decomposes into lead oxide, nitrogen dioxide and oxygen gas. So before you write down these observations, look at the reaction ones. It'll give you an idea.
And the first decomposition, that was the decomposition of carbon dioxide.
नहीं reactant like किसको heat कर रहे हो? Calcium carbonate, uska decompose. That is the one being decomposed into other things. Okay, this is decomposition of lead nitrate. So once you're ready, let's start this. Okay. So lead nitrate, this is the salt. You can see it looks white. Kind of looks like table salt, but don't eat it. So this is how decomposition takes place. So this is another thing. Physical state scale, if you want to note it down. Salts ke decomposition, you don't mix it in water or anything. You do it in solid state only. Say directly test tube ya kisi isme dal ke you directly do it. So initially white salt that you take is lead nitrate. And slowly you can see the color changes. Fumes are more noticeable.
I didn't get that. Could you try again?
Yeah, let me repeat that. Brown fumes, you can see some gases being produced. Multiple gases being produced, in fact. So when you introduce a glowing splint, you can see it burns brighter. So what supports combustion? That tells you the presence of oxygen. So you look at each observation one by one. So pehle, lead nitrate is white in color. So that's what you took initially. So as you keep heating it after some time, let's see what it changes to. So this has become a yellow salt. So yellow, lead oxide is yellow in color. So because color change hua, we can say lead nitrate changed to lead oxide. So brown fumes, brown is characteristic of nitrogen dioxide gas. That's what's produced here. And this glowing thing burning brighter tells you that oxygen is produced because oxygen supports combustion. Okay. Coming back to the reaction, yeah. So lead nitrate, PbNO3 twice on heating gives you lead oxide, which is PbO plus nitrogen dioxide, NO2 plus oxygen. So Harek ka, like note down these observations because questions may this is kind of how you'll be given. Like a white salt X on heating results in a yellow precipitate along with brown fumes being liberated. So you need to remember brown fumes matlab nitrogen oxide, yellow solid is lead oxide. So X should basically be lead nitrate. Okay. So note down the observation. Agar kisi ko fir se dekhna hai to let me know, I'll play it again. Look at the reaction.
Ma'am, brown fumes liberated, will they be solid or will they be gas?
Fumes matlab gas. So brown color gas, look kind of like smoke. So I'll play the video again, like look at it. Also note down that lead nitrate is white. इसीलिए तो color change हो रहा है. White is turning into yellow. And NO2 is basically brown fumes. glowing splint reignites is because oxygen. Oxygen supports combustion. So अगर ज़्यादा oxygen है तो burn brighter. So once we are coming towards the end of the chapter, once we've seen a lot more reactions, I'll give you guys a kind of a cheat code. Like lead salts, agar precipitate ho raha hai, to they're usually yellow in color. And copper salts usually blue in color. So metals, characteristic metals के अपने colors होते हैं. So it'll be easier to figure out. Yeah, Tia, what's up?
Ma'am, can you please explain me the meaning of the third observation?
Glowing splint reignites. Okay. Splint is basically that stick you saw, right? Like they put it in fire and then put up jar fire, but it's not completely put out. Thoda glow hone diya, like that orange glow. Like think of matchsticks as or candle wick. So before it completely goes out, so this it's still hot, but the flame is not there. It's like in that glowing stage, right? It reignites. Matlab, so it is pushed by something to burn brighter. So how do you figure out कि it is burning brighter? So fuel वहाँ पे है. Burning के लिए what else do you need? Oxygen is there. So oxygen is a supporter of combustion. इसलिए वो reignite हो रहा है. नहीं तो नहीं होगा. Otherwise it would have gone out completely. So that's why.
And ma'am, that yeah, ma'am, you can go ahead. Ma'am, in that white you have written the lead nitrate.
हाँ, lead nitrate का color is white, and lead oxide this is yellow.
Ma'am, I have a doubt.
Yeah.
Ma'am, what is the physical state of lead oxide?
Solid.
Okay. And solid is same for lead nitrate.
Yeah. Okay, I'll just play it again. So observe कि क्या ले रहे, कैसे ले रहे, get clearer. Let's literally think of if you took a spoonful of salt, कैसे रहेगा? It's like similar stuff. Texture wise also it'll be pretty similar. White color, solid. So brown fumes है. So this is gas. Like कोई solid produce नहीं हुआ. The only solid that's produced is the white turning into yellow lead oxide. So baki the brown one is all gases only. You can see it's here. In fact, I think later on in the clip, they show you a close-up also of this brown fumes escaping. So reigniting is like it glows brighter because of the available oxygen it's produced. So this you see like salt hai, white color ka. So after some time, yeah, let's stop moving. It is like yellow layer form. So this is all the lead nitrate that has decomposed already. Lead oxide ka layer hai. Next one, brown fumes, the gases that are there. So look at the mouth. Look over here. Look carefully. You can see like brown color gas escaping. So that's lead oxide. Yeah, so clear here. There you go. Okay, so that's brown fumes. Oxygen you can't see with your eyes because it's like colorless. Utna detect nahi hota hai. That is why you need to use a glowing splint in order to figure out if oxygen is there. Okay, so this is thermal decomposition. Next we have photochemical decomposition. So photochemical decomposition, again, it's decomposition reaction, photo, light. Yeah, now what's up?
Sorry to interrupt, ma'am. Ma'am, I didn't mean to.
What? You didn't what?
I didn't mean to interrupt, ma'am. Sorry.
No, you have your hand raised. Okay, I thought you had a question or a doubt or something. Was that by mistake?
I had a question.
To ask.
Okay, ma'am. Ma'am, so lead is a metal, and that, of course, nitrogen is a non-metal. So it like reacts when when a metal and a non-metal reacts, it forms salts. So is that why the PbO3 is salt? And also when it is a salt, it can react with acids and bases, both of them, right?
Not particularly. Like, you're right up to the fact that, see, ion se bana hua hai. You have lead ion and nitrate ion. So ionic compounds, usually you call them salts. Like agar metal and non-metal ke ion se bana hai, so you call them salts. So lead nitrate is a salt. It's not table salt, it is a salt. Like chemistry mein, salts are a type of compound like acids and bases. The next part that you said, that they react with acid bases, that's not necessary. Like your table salt NaCl does not react with any acid or bases. But some of the weaker salt, like your sodium bicarbonate and all, they react with acids. So you can't just say that salts react with acid. It depends on which salt you're looking at. Some salts react, some salts don't.
What does it depend on? Like, why does table salt not react with any acid?
That depends on what that salt is made up of. So we'll, like, your next chapter is all about acids, bases, and salts. So we'll go deeper into that. So it basically depends on whether if it's an acidic salt, it will react with bases. It's a basic salt, it will react with acids. And what decides whether it's acidic salt or basic salt is, it depends on what ions it is made of. Like kaun se acid, kaun se base se aaye hai ye ions.
Ma'am, so ma'am, lead is basic and so is nitrogen.
No, nitrogen is not basic. Nitrate ion comes from an acid, a pretty strong acid. It comes from HNO3, nitric acid. Lead, being a metal, is basic, but the level of its basic nature is low. It's not very basic. It's not as basic as sodium, potassium, and all of these other things. Okay, so if I were to bet on it, this may react with the bases. This will lean more towards acidic salts.
Thank you, ma'am.
Right. Cool. So into the next part, photochemical decomposition. Photo light related decomposition. So you expose it to light and then the decomposition reaction happens. You guys have seen a reaction similar to this, decomposition of silver chloride. So you guys have done AgBr, silver bromide wala reaction, when you were practicing balancing. So that also happened in the presence of sunlight. So silver chloride, when you expose it to light, decomposes into silver and chlorine. And it's called the photography reaction because before we had digital cameras, so when people used to still use negatives and needed to develop that photograph and all that, it was a lot more sophisticated than this, but this was like the basic reaction that was used. So they used silver chloride or silver bromide, expose it to light, put a negative over it, and then let the photos develop. Uske baad, obviously, like binding chemicals and all to preserve that, wo sab karna pada. But yeah, this was like the basic principle of it. So once you finish noting down the reaction, I'll play the video. Cool. I can see Arya, Priya, Mahak, Gautam, Arna are ready. Sujak's finished. Kashvi, Krisal, Ashka, and Parvati.
I'm done.
Yes, ma'am. Even I'm done.
Okay. Cool.
When it's dry, take it out and then place on top of it a template of something you want imprinted onto the silver chloride.
Okay. So like we missed the beginning part of it. So what he made is he made fresh silver chloride. He dried it, cleaned it. He put it on this white color filter paper. So once it's done, then he put like a transparent thing with this text on it. Okay, that's what happened so far.
Then place a sheet of glass over the template to hold it flat and steady. When you're ready, shine a very strong light onto the silver chloride. Over the course of 10 minutes, the silver chloride will decompose under the light to form a negative image of what was placed over it. Modern photography is much better and faster, but this experiment shows you the basic idea. After 10 minutes, remove the glass in the template. And now you have a negative photograph of the template.
It's much clearer. So you can see what's happened here, right? So where the text was, where the black color text was, wahan pe it's white in color. And other parts that the white salt was exposed to has turned gray. So can you identify what this gray substance is?
Silver.
This is silver, correct. So you started off with silver chloride. So jo bhi wo black color is pe, like whichever was not exposed to light, that still remained as silver chloride. So that was still white in color. That's still the salt that is there. But all the other regions that were not exposed to it, all around it, the gray color part, decomposed into silver metal and chlorine gas. So chlorine is gaseous at room temperature, so this escaped off. So the gray substance that remained here is silver metal. Okay, so that's the whole point of negatives, like photo negatives. Have any of you seen photo negatives? Like, were you alive at the time? Any of your parents use those cameras? No, pura digital hi tha, like by that. For your age, okay. I'll see if I can pull up negative ka this thing. Well, yeah, let's finish this video.
And now you have a negative photograph of the template.
Okay. Yeah. So let's see photo negatives. Yeah. Does this kind of look familiar to you? Seen it somewhere, anywhere? Okay. So photography may, like you use these negatives. So when you click the picture, whatever picture you click kind of gets recorded here, but it is a negative. So sab kuch reverse ho jayega. So whichever is bright in real life becomes dark here, and whichever is dark in real life becomes bright over here. So when you develop it, you basically kind of use a reaction similar to this. You expose that negative onto the page where you want to print out the photograph. And again, like the darker areas become lighter on the actual photograph and the lighter areas become dark over there. So that's kind of how the photography works. Okay. But yeah, so just for your information, abhi ke liye, decomposition of silver chloride, silver bromide, these salts are basically used in photography because they're light sensitive. So that's their application. Okay. Cool. Guys, is it clear? Are you with me? Krisal, Gautam, Kashvi, Ashka, Parvati?
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Cool. All right. Next one, electrolysis. Yeah, from the previous batch, I got to know that ये जो 7th या 8th में होना था, it got deleted from your syllabus. But still, how many of you are familiar with electrolysis? Have heard of this or done this before, or come across it before? Okay, Arna is familiar. Okay, none of the rest of you are familiar with this. Okay, no problem. We'll deal with this. Okay, all right. So note down the reaction first, then we look at the other specifics of this thing. Decomposition of water. So if you want to get hydrogen, oxygen back from water, you can use electricity to do that. So this is the reaction. Water splits into hydrogen and oxygen. Hydrogen released at cathode, oxygen released at anode. You can note it down, but I will discuss what is cathode, what is anode, like all of those details in a bit. So tell me when you finished writing this down, then I'll play the video stuff. Okay, Gautam is done. Arya
I'm done.
Parvati is done. Faisal, you finished writing? Okay. Arna is also finished. Ashka is done. Okay. Kashvi, let me know when you finish.
Yes, ma'am, I'm done.
Cool. Okay.
I'm going to show you an electrolysis of water setup. So we have a mini Hoffman apparatus, and I'm going to take this little test tube here. I'm going to dip it under and fill it completely with a 3 molar sodium hydroxide solution. I'm going to do the same with this one. So since we're starting with that completely filled up with solution all the way to the top here, it's going to allow us to collect gases in each of those. So we're going to run a red lead to the negative terminal of the battery, a black lead to the positive terminal. And when we do that, you can see bubbles starting to originate in there. I'm going to zoom in so we can see that up close. And that gas is collecting on the left and on the right. Over there. So we're going to let that run until we've collected enough to make a measurement.
So because once you connected the terminals to electricity, you can see that the process. Okay, this is a fast forwarded process. Okay, one thing I want you guys to observe here is, oh good, he's shown the measurements also. One test tube made, the gas is filling up so much faster than the other test tube. Okay, so here we've got like more gas produced. We got in this test tube we've got like less gas produced. So can you identify which is hydrogen, which is oxygen? In which test tube do we have hydrogen? In which test tube do we have oxygen? Or do you think both are mixed up in both the test tubes?
Ma'am, the one that is positively charged will have faster movement rate because both hydrogen and oxygen are negatively charged, so opposite charges.
No, that is not the reason, Arna. Good try, but like no, that's not. It has to do, like you can figure it out based on the quantity itself. Remember, this is.
I think so. The lesser one will be oxygen, and the more one will be hydrogen. Or is it the other way around?
Okay, so which one is it? lesser oxygen, more hydrogen, or the other way around? Which one are you going with?
Lesser oxygen.
Lesser oxygen. So this is what Parvati is saying. This is oxygen and this is hydrogen. Okay. Okay. Anybody else? Any other answers? Anyone else wants to give it a try?
Ma'am, can we find it out based on the mass of both the elements
Yeah.
in the compound?
Find out. Yes, absolutely. Rather than masses, like we can find out based on the atoms itself. But before I explain, before I go forward, I want to see if anybody else wants to give it a try. Anyone? Srijak? Gautam? Yes? No? Okay. So Parvati, what Parvati answered is absolutely right. The one with more gas, left side is hydrogen, and the one with less gas, right side is oxygen. So Parvati, can you tell me the reason why you thought this is hydrogen with this is oxygen?
What I thought at first was that in the water compound, we know that there are 2 atoms of hydrogen and one atom of oxygen, and it is in the ratio of 1:8, I guess. So taking that into consideration, we should have oxygen less and hydrogen more.
Nice. So you don't have to consider the mass. If you consider mass being ratio 1:8, this will confuse you because oxygen ka mass zyada hai. So don't go with masses at all. Go purely by the number of atoms that are there. Okay. Srijak, you had raised your hand. What did you want to?
Yes, ma'am. I can try explaining that. So anion is electronegative and cation is electropositive. So here it is that hydrogen is released at cathode. So it is related to, is it related to cations? Because cation is electropositive and the positive wire is connected to this thing.
Yes.
And the negative wire is connected to this anode.
Yes.
Oxygen.
So
on anode.
Correct. So Srijak, the answer you have given, like what you said is absolutely right. But that would be the answer to why is hydrogen at cathode and why is oxygen at anode. But this is like first step, like we're trying to identify which one is hydrogen, which one is oxygen in the first place, right? So if you've lost track of the cathode anode, another way you can figure it out is look at the quantities directly. So as Parvati said, so decomposition of water hai. Better way, like this is the most direct way of identifying it, but a better way of putting it is, can anyone tell me the reaction for decomposition of water? So when water decomposes, kya aega?
2H2 will give H2 plus 2H2 plus O2.
Okay, so this is the thing, right? So if you look at the number of molecules, water theek hai, like this whole tank has water, but the gases that are produced, we have 2 molecules of hydrogen for every molecule of oxygen that is produced here. So if you have to multiply it by Avogadro's number, we have 2 moles of hydrogen for every mole of oxygen that is produced. So twice the quantity of hydrogen produced compared to how much ever oxygen is produced. Okay, so that is what is being reflected in the test tubes also here. You can see the measurement here. Yahan pe hydrogen has reached almost like 5 units, whatever it may be, 5 ml if we consider. Oxygen will be half of it. So you can see that that's approximately at 2.5 here. Okay. So that's a characteristic. So based on the reaction, you can also, again, that's the whole point of balancing equations. You can figure out ki kitne reactants, kitne products are there. So in the case of decomposition of water, twice the amount of hydrogen for every amount of oxygen produced. And the reason, as Parvati said, if you look at the formula of water, you have 2 atoms of hydrogen for every atom of oxygen. Usi se aa raha hai basically eventually. Yeah. All right. Now coming to the cathode, anode, electrode, and all that. Okay. So just a little bit of crash course on electrolysis. I'm gonna rewind this to show you guys the setup that he has over here. Okay, so this is the setup he's done for electrolysis. Electrolysis matlab decomposition due to electricity. Do you guys know how electricity works? Like, tell me whatever you know of electricity. Like, we'll start from there. Yeah, Arna.
Ma'am, electricity is produced like by photons, if I'm not wrong.
No, you are wrong. Photons is light.
Light, but
Photons, yeah, all of that
made
is
of electrons.
electrons. Electricity is electrons. It's right there in the name directly. Okay, so electricity is literally flow of electrons. So it has to do with charges, like you have positive terminals and negative terminals. You guys must have seen your dry cell, your AA battery, right? This, if not this sort of a cell, at least the ones you put in your torch or like torchlight, remote controls, all of that. So dry cell में क्या होता है, like कैसे दिखता है? Source of electricity, tiny cylinder. यहाँ पे एक छोटा सा ये होगा. So this is a positive terminal and this is a negative terminal, right? So electricity, source of electricity हमेशा batteries में एक positive terminal होता है, एक negative terminal होता है. Now electrolysis कैसे होता है? So electrolysis is you need to give electricity to the water present in this tank in order to split it into hydrogen, oxygen, right? So how do you get electricity to reach here? Is you use two rods. Okay, so the sole purpose of this rods is to get electricity to water, because you can't like just put a battery randomly in water. That's not how it works. So these rods, they are called electrodes. And depending on where they are attached on the battery, so the electrode attached on the positive terminal is called anode, and the electrode attached to the negative terminal, this is called cathode. So this ties in with what Srijak was mentioning, कि ये negative terminal से connected है, so this has a negative charge. ये positive terminal से connected है, so this has a positive charge. So anode के पास जाएंगे anions, so in this case oxygen के ions, and cathode के पास जाएंगे cations, like negative positive attraction, right? So in this case, the hydrogen cations. Okay, so that's why at the cathode, at the negative terminal, you end up getting hydrogen gas, and at the anode, at the positive terminal, you end up getting oxygen gas. Like basically, once you have electrodes, this is basically dipped in water. Main points. दो electrodes होते हैं connected to the battery. So battery has a positive terminal, negative terminal. So the electrode connected to positive is anode, electrode connected to negative is cathode. And opposite charges attract. So anode attracts the anions, the negative ions, क्योंकि उसका charge है positive. And cathode attracts the cations, the positive ions, क्योंकि उसका charge है negative.
Ma'am, but aren't both hydrogen and oxygen having negative charges?
That's not true. Hydrogen has positive charge also.
Ma'am, how come?
You think about it. Like charges attract or repel each other?
Repel.
तो अगर हाइड्रोजन के पास भी नेगेटिव है, ऑक्सीजन के पास भी नेगेटिव है, तो will both of them be able to form a compound?
Ma'am, like by covalent bonds.
They are covalent. That is correct. But both of them do not end up getting the electrons. Like itne sare electrons nahi hai na. So if one of the atom gets electrons, the other one has to lose electrons. Is that correct? Like when we break the bond. So oxygen has a tendency to attract electrons towards itself. So this basically splits. So oxygen takes the electrons all for itself. So you have oxygen ions and hydrogen ke cations.
Ma'am, I couldn't, like, after HOH, could you please repeat? I couldn't hear you.
Yeah. So when electrolysis happens, the bond needs to break, right? So oxygen has a tendency to gain electrons. That's why it forms oxide ions. Hydrogen has a tendency to lose electrons. Like it also gains electrons, but it's in very specific cases. Majority of the times, like even when you come across acids, like if you have HCl, H2SO4, so all of these, when you dissolve, you're going to get H plus ions. So even in this context, because oxygen has a tendency to gain electrons, hydrogen loses electrons and it forms H plus cation. So it goes towards the cathode.
Okay, ma'am.
Okay. Cool. So these are like the major concepts you need to know about electrolysis. So electrolysis, say, like basically you're using electricity to split compounds like water, also used to split NaCl into Na plus and Cl, sodium and chlorine gas. How do you split them? You use electricity. So electricity matlab you end up having two terminals. You have a positive terminal, negative terminal, and quantity of both of these is decided by the composition. Kitne hydrogen, kitne oxygen hai, all of that. Cool. This is electrolysis. Okay, the next type of reaction, displacement reaction. So what do you mean? Like, what is the meaning of displacement, this word? What do you understand by displacement?
Movement.
Taking someone's place.
It displaces a substance.
Displacing it, right? So reaction may be wahi ho raha hai. So reaction in which a more reactive ion replaces a less reactive ion from its compound are called displacement. So it usually follows this format, like if you have AB plus C. So this one takes the place of, gives CB plus A. And this will happen only if C is more reactive than A. So if C is more reactive than A, it is capable of kicking A out from the compound. So takes the place of A, so forms CB, and A is kicked out, it becomes an elementary. So this is your basic displacement reaction. So C displaces A from its ionic salt. Okay, so tell me once you've finished writing, we will discuss more about this.
I'm done.
Okay. Yeah, now what's up?
I'm done.
Like as you said, hydrogen also has a tendency to lose electrons. Is that why acids like are also formed?
Yeah, exactly.
Like
So
that is why acids are
these
only formed, right?
photons-
So that they react accordingly.
Yeah, so acids have H plus. So, yeah,
Yes.
properties of acids. Anna is writing, Gautam is writing. Tia, Crystal, Ashti, Arti, and Ashka are done. Okay. So, oh, Kashvi is sent. Share the slides. Yeah, sure. Either this class or maybe next class. Like the whole chapter will be done. And I need to make a couple of changes. Like I realized the videos that I used, they've changed their settings. They're not available here. I need to replace those videos. Once that's done, I'll share the slides. And after this chapter, I'll also share the playlist of all these videos with you guys. Whatever I've put in the the PPT, there's also a YouTube playlist of all of that, so I'll share that with you. Cool. Everyone's done. Looks like. So, reactivity series. This is something you guys might be familiar with. Pehle kiya hoga metals, non-metals when you're studying about it. Why is this important? Because of this little thing that we saw here. A more reactive ion can replace a less reactive ion. So things on the top of the reactivity series are able to replace the elements that are below them. So that's why the series gets important. If you're able to memorize the series, excellent, awesome. But even if you're not, don't worry about it. Just have a rough idea of which ones are more reactive, which ones are less reactive. At this point, that's all you need to care about. So have an idea of what comes right at the top. So a lot of the metals that you will find in salts, like potassium, you'll be familiar with KOH and all. Sodium, NaCl mein hota hai. Calcium, you have quicklime, limestone. So these sort of metals are right there on the top. Middle of the road, moderately reactive, are the metals you would use in your everyday life, like iron, steel, and all iron utensils, iron equipment. Zinc, find in medicines and all. Tin, like your tin cans, tin foils, all of that. Lead, you have lead pipes. So these would be somewhere in the center. And right at the bottom would be noble metals. Like you have copper, silver, gold, platinum also comes here. Mercury also is like somewhere in the bottom. Okay. So have a rough idea of subse on top, what kind of metals you'll find. Middle mein what kind of metals you find. Bottom, what kind of metals you find. So once you're familiar with it, like once you have a correct idea of all of that, then you can, consider memorizing the exact mistake. But at least for now, to start with, have an idea ki most reactive metals kaun se hai, moderately medium reactive kaun se metals hai, or not unreactive kaun se metals hai. Just remember that much.
What did you say for the most reactive? What do they are used for?
So less reactive are things that you are familiar with, like silver, gold, copper. So these you would find them used as they are, like without any paint, without anything. Like you.
I was talking about the most reactive ones.
Oh, most reactive again. So think of it this way: they are extremely reactive, right? So they cannot tolerate staying in their elemental form. They have to react with something or the other. You'll find these mainly, you'll come across these elements in their salts. So sodium chloride, baking soda, all that have sodium. So calcium, quick lime, limestone, lime water, so stuff like that. Yeah, make a note of it, or if you have it somewhere, that'll work. Like it'll help you if you make a note of it, like keep it somewhere, so you can keep referring to it. Because all the displacement reaction basically depend on this only. Okay. So are you guys noting this down, or can I go to the next slide? Some people are noting down. Okay, like finish it and then we'll go to the next one.
Excuse me, ma'am.
Yeah.
Actually, you said that you would check upon the workbook and all that.
Yeah, Kashvi. So yeah, checked it. So tomorrow or day after they're going out for delivery. So printing and binding has taken place. So we'll do that.
Thank you.
Yeah. So we'll do this again in metals, non-metals chapter. Yeah, Parvati, what's up?
Ma'am, it's a bit out of context question, but it is related to the reactivity series, so I wanted to ask. When we check the reactivity in the pH scale, what is the color for pH 8 and 9? Because we already got a litmus paper, the paper, but I don't have the scale for it.
Reactivity is not related to litmus paper one, Parvati. So
No, the pH scale one.
pH scale. Okay, so we're not talking about reactivity at all. So your question is on pH scale only.
But what is the color for 8 and 9 in the pH scale?
Okay. So if you're looking at the universal indicator, neutral, so the more basic a substance gets, the more bluer it is. So 8 and 9 would be somewhere between like slightly greenish blue, that tinge.
Okay, ma'am.
Okay, finish. Okay. This is an example of displacement reaction. How many of you had gone to the lab today in your school?
Oh, we had gone yesterday.
Oh, you also have gone yesterday. So most of you must have seen this reaction in real life. Looking at displacement of copper by iron. So if you have pure iron, like basically iron nail, dip it in copper sulfate solution. Yes, Rija, was that from before or do you have a question? From before, okay. So reaction happens because, again, if you look at the reactivity series, iron is upper, copper is niche. So iron is capable of kicking copper out from its salt. So iron displaces copper. So you get copper metal and the solution becomes iron sulfate ka solution. Okay. So Another hack, so copper salts are blue, like copper sulfate is a brilliant blue color, copper chloride, copper nitrate. So copper salts are usually shades of blue, like dark blue, light blue, teal, that. Iron salts, when it's in +2, like iron sulfate, is a green solution. Okay. So we look at the video of what happens here.
One of the most common errors to occur in common entrance chemistry is in describing the reaction between copper sulfate solution and iron, in this case in the form of a nail. If I place a small amount of copper sulfate solution into this beaker and place the iron nail into the solution for a few seconds, a reaction takes place. The nail soon becomes coated with a pinkish brown deposit.
There you go. Copper.
When this is mentioned in common entrance questions, the mention of a brown solid in conjunction with iron often leads candidates to think that this brown deposit is rust.
But it is
However,
not.
this is not correct.
Copper.
Iron, being more reactive than copper, displaces the copper from the copper sulfate solution. The brown coating on the nail is copper.
So you can see that, okay, copper has been displaced, copper hai yahan pe, but solution is still blue in color. Like, why is that? So reaction nahi hua, like, do we still have copper sulfate, but copper here also?
Ma'am, it has not completely reacted, it has only reacted with the nail.
Yeah, absolutely. So there has been a reaction, but यहाँ पे बस ऊपर का surface coating ही हुआ है ना copper का. So there's not enough iron in the solution to change its color. So give it some time, then as you get enough iron sulfate, the color is going to change. So we'll see what happens.
If this reaction is left to proceed for several hours, a large amount of copper is displaced
There you go. That's the color
from the
change.
copper sulfate solution.
So you can see how much copper has reacted. Like instead of being a smooth iron nail, you can see like lots of copper there's a bunch of copper on the nail. So this much reaction was necessary in order to like change the whole color of this thing. Okay, so you have.
And iron takes its place to form iron sulfate solution, which is the green color that you can see in this beaker.
Yep. So that's displacement of copper by iron. That's one example. This is the most visible visual example because you can see the color change, you can see the copper depositing and all of that. Okay. So iron nail dipped in copper sulfate. So iron nail gets coating of copper. Now copper sulfate originally blue tha. Once a reaction happens, turns into green color iron sulfate. Okay. So if you guys have noted the reactivity series down, we'll do a few more example like practice of the displacement reactions. Okay, everybody's done? Okay. All right. So if I use aluminium, plus iron oxide. Okay, so figure out first if this reaction will take place or not. If it takes place, send the products on the chat, like, or send me the balanced equation on the chat. So first thing, see if aluminium is capable of displacing iron. If it is, then figure out what the products will be, balance that equation and send it out. अगर किसी को reactivity series चाहिए तो let me know, I'll just quickly display it. Otherwise, work this out and send it.
Ma'am, we have to balance it as well. Okay.
Send it on private. I'm not gonna say whether you're right or wrong, Sujak. Like, I can't say. Keep it answer. Arna sent it. Yes. Gautam, I'm gonna assume that's 3. Okay, 3 and E are close by. Okay, yeah, you got it. Ashka also got it. Good stuff. So 4 people have sent it. Mahak has also sent it. Yes. Parvati, aluminium oxide, that is not correct. Skeletal में formula सही होना चाहिए. Only the balancing will not be there. Also, iron का formula देखो एक बार. Iron is a metal. It's not a non-metal. It's not a gas. Okay, who's yet to send? Arya, are you sending again? Okay. Anna sent, Sujak sent, Mahak has sent. Tia, are you sending? Tia, Chriselle. Kashvi, I got only half. Okay, you sent the products. Close. So, like, refer the valencies again. Yeah, I'll give you guys a hint. Aluminium always takes +3 valency. Iron, in this case, it is +3. Oxygen is -2. So Kashvi, like, work it out again and send it. Crystal, yes, balanced है. सही है. Arya, Arya, absolutely. Arya, you have like a very beautiful writing, proper cursive. Do you do calligraphy or something? Ah, you're not audible. Can't hear you. What do you say? No, still. Can anybody else hear Arya? Is it just me or no? Can't. Oh, you have muted. इसलिए. Unmute yourself. Oh no, still can't hear you. It's like your mic is not connected at all. So just check settings or something. So Kashvi, absolutely right. Aluminium is going to replace iron, but the formula is wrong. So that's where you need to revise once. So this will be Al2O3. Again, Al is 3, oxygen is 2, crisscross. So Al2O3. हो जाएगा. And iron, this I thought, yeah. And iron, this a couple of you have made a mistake here. Iron will be just Fe. So metals, hamesha you write it as their single symbol, like atomic symbols itself. Only non-metals exist as H2, N2, Cl2 and all that. So we come across a metal, like aluminium is just Al. Iron is just written as Fe. Okay, so if you have sodium pure metal, it will be written as Na only. Any metal will be purely written as itself. Okay. Cool. And in order to balance it, 2 Fe hona chahiye, because there's Fe2, Al2 hai, so this will be 2Al. That's a balanced one. No stupid about this. Okay. So on a similar thing, I'll give you guys a couple of reactions. First, figure out if that reaction will happen or not. Agar reaction nahi ho raha hai, to you can just say no reaction or something like that. Agar reaction ho raha hai, to send me the balanced equation. Okay. So the second one would be copper plus magnesium nitrate. Yes. Okay, figure it out. Quite a few answers. Oh, Srijak, check carefully again. Ashka, okay, that's a clever way to put it, but okay. Arna got it, Mahak got it. You guys got the reason also down with Parvati got it. So 5 answers, usme 4 correct answers. Srijak, you need to check it again. Okay, Gautam, Tia, Chrisel, and Kashvi, what do you guys think? Okay, Kashvi is still working on it. Srijak realized, okay. Yes. Rest of you. किसका नाम पूछा मैंने? Crystal, Tia, Gautam, 3 of you.
Yeah, one.
I'm not getting it.
Not getting it. So first thing, अभी अगर reaction होने वाला है कि नहीं, if you want to figure that out, displacement में what is the condition? If copper needs to kick magnesium out, copper has to be more reactive than magnesium. Is it? Is copper more reactive than magnesium?
No, it's not.
No.
So will it be capable of taking its place here?
No.
So no reaction.
Okay, so it should take out the cation, right? Okay.
Yeah, continue. If we take out the cation, then
Sorry?
no. Were you going to ask a question?
No. I just want to clarify that.
Okay. So that's the key point. Displacement, single displacement reactions में कि whatever element you take here, that needs to be more reactive than this particular thing. अगर anion लिया तो that anion needs to be more reactive, but those cases are lesser. Okay. Now copper is not more reactive than magnesium. Copper likes to stay at itself. Magnesium being reactive likes to stay in ionic form. So this is not going to end up in any reaction. It will stay as it is. Okay. Arya, no. There won't be any reaction that will happen here.
Oh, okay.
Because copper is not reactive than magnesium. Not more reactive than magnesium. Okay. I'll give you guys another one. Same thing. Copper plus silver chloride. Oh, no. Let's take silver nitrate gives. Same question as before. अगर reaction होएगा तो give me the products, balance it out. If there is no reaction that will take place, just say no reaction. Very nice. Parvati got it. Good stuff.
Excuse me,
Yeah.
I wanted to ask, what will we take the valency of Cu? Will it be +2 or
+1?
Okay.
Ma'am, so the valency of nitrate will be -1, right?
Yes. So here also Ag is in +1, nitrate is -1. Ashka got it. Good. Well done. Good stuff, guys. Mahak got it. Mahak, take copper ka valency to be +1, but otherwise based on your +2, like balancing and all is correct. Gautam, yes, got it.
So valency, copper is 2 valency.
Yeah, it has +1 and +2. Usually like silver nitrate is in +1, so copper also, like there's only one electron ka exchange that happens, so copper also ends up taking +1. Ashvi, yes, absolutely. Okay. So here you can see copper is more reactive than silver. Like copper is in the bottom, but definitely more reactive than silver, gold, and platinum. So copper is capable of displacing silver. So you end up getting copper nitrate, CuNO3, and silver precipitates out of the solution. So this is one of the ways you can chemically purify silver. Just make a salt out of it, displace it, get silver out. Cool. So this is how single displacement reactions go. That's why the reactivity series is pretty important when it comes to single displacement reactions. Okay. Next, double displacement, and then we're left with oxidation reduction reactions. We'll look at all of that in the next